accommodate, we go to the next class, which is also the same surface tension, okay? All right. So let's just wait for them. And when it is 12 o'clock, we will start it, all right?
Sorry, good morning, sir. I want to ask, is this class also for engineering students?
Say that again.
Is this class also for engineering students?
That is the right class for engineering students and all other class students that cannot take. When you look at the schedule, you see the name there, Dr. Ogunbemi, engineering and environmental. But all others can also hang in there, all right?
Okay, thank you.
When you ask questions, let me know your name, please. Just introduce yourself. My name is so, and then go ahead and ask about the question you want to ask about, okay?
Okay, sir. My name is Ayomide Oluwatola.
Ayomide. Just 2 more minutes to the class. Yes, come inside. Yeah, in a class online. Quick. I have 2 minutes to that class. I asked him to answer to comment. Sure, only problem here. Okay. Precious, can you come around after this class? This class will end by 2 or 11. You are sweating. Sorry for that. So this is UAB. Can I see this guy too when you are coming? It's not around. Okay. Come on. Just come after I finish this class. Give me 1.5. If you can't get, text me. I'll text him. Yeah. Precious, after my class, I will attend to you. Go for your class now. Or you want to wait? You have a class now? Okay, sir. No problem. Thank you. It's 12 o'clock by my time here. And I believe with you there too, your time should be about that time. Like you see my data and my information on the first slides. So I believe you have it. In case you have any question, you have my phone number, you have my room number, and you have my name. You can come. So like you have, or you have been taught yesterday, that surface tension is observed in liquids. Yes, liquids have as if they have membrane. Yes, there's a fog. Hello?
I cannot see the screen, sir.
You cannot see.
We can't see your screen, sir.
You can't see my screen.
Yes, sir.
It's not the sir.
Okay. Well, I thought somebody said they can see it. Yeah. Where is it?
Yeah, that was before. That was before.
Before Abi.
Then.
Okay, I'm coming on. Because they can see it before, now they cannot see it. How about now?
Yes, sir.
Can you see it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes,
You
sir.
can see
Very
it
true,
now.
sir.
We can see
Thank
it
you.
now. Yeah.
Okay. So surface tension is like you have a force acting on the surface of liquids in which the molecules, they are forced to form a kind of cohesion together that it can never be easily penetrated. If you press into your skin, you see that there's a kind of a force resisting that pressure. In liquid, we experience that. So surface tension property of a liquid surface displays its own acting force, okay? Just like an elastic membrane, okay? Now, for the next slide, please. For the surface tension, look at the diagram you have here. There's the molecule here, and we have forces acting in all directions of the molecule. Excuse me, can you see it now? Hello?
Yes, sir. You are seeing it.
Yes,
You
sir.
can
Yes,
see
sir.
the,
We
can
can
see
see your
your
screen now,
screen.
sir.
thank you,
Yes, sir,
because
we
it's
can see.
disappearing from here.
Sir, we can see it.
Okay, thank you. So you see the
Yes.
liquid molecule, and you see that there's a force acting on it or in all directions. At the surface, part of these forces, which we have in one or two liquids, they act together, and because of that, there's going to be a pull, an extension, like elastic tension at the surface. So there is also a tension parallel at the surface of the liquid. At all times, we observe that. If you are very observant, people that comes from area where you have pond, you will see that you have some insects that stay on top of God, on top of liquid, on top of water. Please mute yourself, please. So the molecules at the surface do not have the same molecules on all sides of them, but there are what we call the force that pull inward towards that. So that insect on the surface of the liquid will be experiencing what we call the surface tension. Remember, we say surface tension because it's tension, it is a force. It is a force. Definition of surface tension: the property of the surface of a liquid that allow it to resist an external force due to coercive nature of its molecule. The word coercive is defined as the force that exists between molecules of the same nature. Yes, force of attraction between molecules of the same what? Of the same nature. That is what we call the coercive force. The coercive force. So surface tension depends mainly on the force of attraction between the particles within the liquid. Take note, somebody is talking. I can penalize you. I can make sure you don't do the exam. Or if I get you, tell him. Somebody is disturbing the class. Thank you. Mute yourself. You don't have to show us where you are. So remember, surface tension depends on force of attraction. And this force of attraction, we call it coercive force. Don't forget about it. Most of your question is going to be multiple choice. Coercive force is what exists between the molecules that enable an insect or material to experience surface tension. So surface tension acts on a line per unit length. It acts on a line per unit length on the surface of a given liquid, okay? Don't forget. So to calculate the first surface tension, we now say it is a force per unit length. Force per unit length. So the formula is given to you as that. And I believe we'll be able to have one or two examples of that. Next slide. In the next slide, there are two forces of attraction for a liquid in a container. Now we are coming to different forces. Remember, we made mention of coercive force. This coercive force is the force of attraction acting between the molecules of the same type. For example, water molecule. the molecules of water are the same. So the force that exists between the molecules of a water is called coercive force. Coercive force, excuse me, also exists within the molecules of mercury. It also exists between the molecules of iron that are of likeness. They have the same type. They have the same type. Don't forget about that. Another type of force of attraction is what we call the adhesive force. This force is the force acting between molecules of different type. I'll give you an example. When you drop oil inside water, you see that the oil is floating or the oil is not mixing with the oil, with what? With the water. The force that keeps the molecules together are different. Another aspect is when you have liquid inside glass. You have liquid inside glass. Okay, sorry, am I going back now? Sorry. The molecules of the glass is different from that of the what? Of the liquid. So therefore, the interaction between the two molecules will differ. So let's take note of that. Remember, you can simply differentiate between coercive forces and adhesive forces. Coercive forces, forces between molecules of the same likeness. Adhesive forces, forces between molecules of different type. Remember that. They are very, very important for you to remember. The angle of contact, here we are now. Look at this thing, look at it. The molecule of glass and the liquid, they are different. So the angle between the meniscus, you know what they call meniscus? Look at the diagram A and B. We have A, it is concave outside. We have B, it is concave inside. This action of the meniscus is due to the two forces we are talking about, adhesive force and coercive force. So let's look at it now. When you see the first diagram here, you see that we have an acute angle. That is the angle of contact for the first liquid. And the other one, we have obtuse angle, which is the angle between the two forces. Let's see what happened now. The angle between the meniscus and the container wall of a column of liquid is measured from the vertical wall. And that is shown here, you see it. So when the adhesive force, very important thing to take note now, when the adhesive force are greater than coercive force, the angle of contact is an acute angle. It lies between 0 degree and 90 degree. Remember, it is only when adhesive force is greater than coercive force. And what is adhesive force? That is the forces between molecules of different type. Coercive force, forces between molecules of the same type. Remember that. The liquid have its molecule held together by coercive force. The gas have its molecules held together by adhesive force. Now, when you put the two substances of different molecules together and the forces of adhesive is greater than that of coercive, the angle of contact theta between the two molecules will be an acute angle. That is angle between 0 and 90 degree. That is a very important statement to take note. I can ask you 10 questions on what I've just explained now. And if you don't know this concept, you may not get it right. For the second one now, when the force of adhesive is smaller, is less than the force of coercive, the contact angle between the two different liquids is obtuse angle. Obtuse angles are angles that are greater than 90 but less than whatsoever 180 degree. Remember that the adhesive force is less than coercive force. You experience angle of contact that is greater than 90 but less than 180, which we call the obtuse angle. These three lines you have here is very, very important. 5 to 10 questions can be asked on these 3 lines. And as a good student, I want you to take note of this concept there. All the noise I've been making since morning now, the concept is based on these 3 lines. Thank you. So for liquid standing in a container in a meniscus form, it can be convex or concave. A concave meniscus indicates that the molecules of the liquid have a stronger attraction to the material of the container. In other words, adhesive force. Now, so let's look at it. The one you have in A is what? The one you have in A is what?
Concave. Water.
So in that case, sorry, my this is that means good. That means the force between the two are very strong. Am I correct? So take note of that. Objective question is what you are going to do in your exam. And all these basic concepts are very, very important to remember, okay? Then, for the other one, that you have convex meniscus, the molecules have a stronger attraction to each other than the molecules of the material and the container. Take note of that. I may not draw this diagram in the exam, and I may produce the diagram and try to convince you to get what I'm saying right. So please take note of it. It is very, very important for you to do that. At the end of this class, I will bring in a kind of a trial question. You write them down, and if you want me to send these slides to you, I will send this material to you all, okay? It is very important to take note of the concept. Thank you. We move to the next one, which we call the capillary. The capillary. You remember when you drop a tube inside water, automatically the tube and the liquid will rise to a certain level depending on the diameter of the tube you drop inside water. That action for the liquid to rise in the tube that you drop inside this is called capillary action. Don't forget about it. So we now say the tendency of a fluid to rise in a narrow tube or capillary tube is called capillary action. It is a definition that you must be able to remember and you must be able to recall it. When we put this definition down in a multiple choice MCQ, if you don't get it right, you will discover that you'll be convinced to pick a wrong answer. And I don't want you to pick a wrong answer. Just pick the one that is right. So if a capillary tube is placed vertically in a liquid, as shown in the diagram below, I already explained that. Let's go to the diagram below. This is the diagram I'm talking about, okay? The capillary, look at it now. There is ability for the liquid to increase. And those that rise up quickly, we call them capillary attraction. That is in which the height of the liquid is above the height, that is the height of the liquid in the capillary, is above the height of the liquid in that container. That is called capillary attraction. Look at the second diagram. We call it capillary repulsion. In other words, the rise in the liquid within that capillary is far below the level of the meniscus of the liquid inside that container. So remember to differentiate between the two. So I take you back to the next slide now, to the back slide. Mercury is suppressed in a glass tube because its contact angle is greater than 90. And that is what you experience here, that mercury will not go higher. Instead of going higher, it is suppressed because the contact angle of the mercury is what? Is optics angle greater than 90. Take note of that. Not only that, surface tension exerts a downward force as it flattens the mercury. Very, very important point to take note. Suppressing it in the tube, making it to decrease, making it not to rise above the liquid of the container when the capillary is put into it. Take note of that. For water, water will rise in a glass tube because its contact angle is what? Is acute, nearly zero. Surface tension therefore exerts an upward force when it flattens the surface to reduce the surface area. Now here we are. Look at the diagram here. The liquid increases in height because the contact angle between the glass and the liquid is less than 90. Okay, it's less than 90. We need to take note of that. These two diagrams alone can produce another 5 questions for you in a class. Okay, so now let's look at the relationship between the angle of contact, between the height of the liquid as it increases or decreases in the capillary, and the radius of the capillary we put in there, and the force that suppresses the liquid within the capillary. We try to find a relationship between that. Okay, so note one thing again. Adhesion and surface tension together can produce capillary action. Don't forget about that. Multiple choice question. Keep this one in your left hand. Don't use it to eat donut. Adhesion and surface tension together can produce capillary tube. The question now, which of the following pair can produce capillary action? And I will give you different options. But note that the correct answer will be adhesion and surface tension. Capillary action occurs when the adhesions to the wall is greater than I already explained that. So let's go to the relationship. Here we are. The angle, the formula here is very, very important for you to memorize, to recall at any given time, because you might be given questions either to calculate the angle of contact, to calculate the radius of the capillary, or to calculate the height of the liquid inside the capillary. What you
Cannot hear you again.
I think it's his connection.
Sir, I think I'm muted.
Sorry, can't hear you.
You can't hear you again.
Sir, we can't
No.
hear you. Sir, we can't hear you.
Connection problem. Oh, you guys chill.
Like it's connected.
Stop for me. Stop.
Hello, sir.
Is it still there?
I don't
What did you?
He should still be there. I think his screen has come down. No, he's not there again.
Not there again. His connection is fluctuating.
I think
so you guys have
the
to wait.
network has logged him out.
Yeah.
Log out. Yes.
You
The
have to
network.
wait.
He also did the same to me before. He will soon come back.
We can come back, but you guys wait.
Let's just wait.
On my network problem is The network also logged me out before.
Or maybe somebody call him so he interfere with his network.
That's true.
Maximum capacity. How is it going to enter?
300. In the end meeting, I think there's another host there now.
No, now close your mouth first. Close your mouth first.
Someone should go down for him so that we enter.
I should leave now.
You can leave now.
You can go.
Boss, you still person maybe saying leave. You know if you leave yourself.
Look at the bottom left of your screen. There's one microphone there. You guys should just tap on that microphone first. Let's see something.
One person should leave now.
If one person leave, another person will enter. So nobody to leave.
You guys should leave space for the man to enter, or let him not close room and go and start again.
You come out now. Why
What
leave and
What about you?
problem solved?
We don't have to close it.
Yes, they will close this room and start again. Because when the YouTube link has stopped, sir.
Anyone now, first student, like, if it's login again now. I go room one person in my own hand. Oh. I be host.
Wow. Who be this Tottenham fan?
Now, Tottenham had to be.
She Tottenham get fans.
This guy will get they put
Yeah, bro. One on one corner. No start argument.
I go mute all of you now with this group,
Una
with this
bad
call.
bastard.
Please mute your mic.
I no be shy.
One person don't come out, I don't come back home.
Since we already have the PDF, you guys can still continue with the PDF rather than waiting for him. We already shared the PDF since
you
on
can go
Wednesday.
now.
So you can just continue
You
from the
can go.
PDF.
You don't have to wait for him. You can go.
But there's a
You go
PDF, I
read
beg.
the PDF now, no worry.
Yeah, you go so that there will be space for
Me,
the
I
host
signed
to
my
come.
here sef. I think go
Make
submit.
sure you start shine attendance before you come up for this call.
I beg me, I don't get PDF. Oh.
The PDF they
Goes
group
on,
now.
goes on,
Please
goes on,
send it to
goes
the group
on.
now. Send it to
Which group? Which group? Which of the
You
groups?
just goes on.
PVLES or EE.
Group just plenty for you.
What is
Now the
that?
PDF
Which one is
is there.
EELES?
I'm moving with the PDF sef. I've already finished everything. I just wanted to see the man explanation.
No one has.
Yeah, I beg.
Okay. We don't
I
hear. Oh
beg.
yeah,
Shey,
close your mouth.
I
You
beg.
can
Shey
go
if you
now.
said now, give us. I beg. Me, I don't get the PDF.
You
Oh.
can post it on the chat or something like that. You can post it on the chat. You should be able to post it on the chat.
I don't get the PDF. Oh.
Finally.
Guys, you don't come.
Not bad.
You don't
Yeah.
come. You don't come.
Welcome back, sir.
Sorry, sir, we can't hear you. Be careful.
And why this online class? No.
Hello? Excuse me, hello?
We can
Hello,
hear
sir.
you.
We can hear you,
You
sir.
can hear sir. You can hear sir.
Emmanuel,
Sir.
can you mute
Yes, but we
yourself,
can hear you,
Emmanuel?
sir.
I
We
have
can
your
hear you,
matric
sir.
number here. Baba Sunday favor too. Can you keep quiet? What kind of a student are you? Karim, can you mute yourself? Go ahead and mute it. Mute yourself. If I get your matric number, I'm going to deal with you. All right, now listen to me, everybody. Listen to me, everybody. So you must be able to calculate H, hello, the height of the liquid. And you must be able to play with the formula we have in here. All right? So the next one is wetting the glass. Wetting is the ability of the liquid to form interfaces with liquid surfaces. That is very, very important. Wetting is the ability of the liquid.
We can't hear you, sir.
Hello, can you hear me now?
Yes, sir. Yes, sir.
Okay. So
sir, we
please,
can't hear
let's
you.
have decorum in that class, please. You see that formula? That formula is very important for you to be able to recall and use as at when due. Okay? So the contact angle theta between the liquid and the surface, solid surface, is measure, yes, okay, is a measure of the degree of wetting. Now let's look at it. If this angle is small, the surface tension results in a greater
We can't hear you, sir.
Greater degree of wetting.
Please, I'll go and buy this.
Maybe it's not like network stuff where it is. I don't know.
If I mute you and you put it on again, I will write against you. I will write against you. If I mute you and you put it up, I'm going to get your number down and submit it to the authority. Usman, can you hear me? Usman, if you bring yourself up again, I'm going to write your name down and submit to the authority that you are disturbing the class.
Sorry, sir.
Yama, you are a good example. I got your name down, Yama. I'm going to look for your matric number. Lami Yama. Okay, thank you. Let's have a decorum in that class. The one without name, I already removed him or her. No name, I already removed that. Why is it vibrating again? Why is it vibration? Let's be disturbing the class. All right, so the angle theta, when it is 0, you see how much wetting you are going to have. When theta is 90, less than 90, you see the degree of wetting we have. When theta is greater than 90, is called the wetting. That is called the wetting. That is very important for you to take note. The relationship between the angle of contact and the wetting. A smaller angle of contact and a smaller surface tension will result into a greater degree of wetting. That is very, very important for you to take note of, okay? The next thing we are talking about will be the example of a soap. Okay, surface tension is the reason why soap form bubbles and droplets. Take note of that. I believe you have taken note of this or this phenomenon when you are washing clothes. You will see that the soap will form bubbles, droplets. When we are small, we normally play with that and you see it going up and down. Ibi tó ti pé kìíní síbẹ̀. So it is possible to calculate the pressure exerted on a spherical bulb that you play with when we are small, and the relationship between that and the surface tension is given. P equals to 4 gamma all over R, where R is the radius of the bulb. Okay, so bulbs have two surfaces. You remember there is internal and the outside surface. So inside that bulb, we have air, and then we have a thin thickness. So the force from form of the surface tension F will be equal to 2 gamma L, 2 gamma L, 2 gamma L. And in this case, the L is the thickness of the soap. Don't forget. So you can also calculate that. And again, a bulb can also be spherical in volume, for example, a gas in a liquid. So that P will be divided by 2 because of the two surfaces. P equals to 2 gamma over R. So let's look at examples now. Calculate the gauge pressure inside the soap bulb of radius 2.010 to the power of 4 meter in radius using the surface tension of soapy water. Gamma is 0. The same guy, no ló ń ṣe kínní. Gamma is 0.0370. So the pressure will be 4 gamma all over R. So substitute what you are given, and you're going to get your answer. And the answer will be Newton per meter square. Newton per meter square is the unit of pressure. Newton per meter square is the unit of pressure. So therefore, that is an example on how to calculate that. The second example says calculate. It's vibrating, huh? Because I said it. I'm repeating. Now, they did it. They don't know how to do it. Calculate the radius of a capillary tube that will raise a slope 100 meters to the top of a giant redwood, where gamma, the surface tension, is 0.073, assuming that the surface density is 1,050 kilogram per meter cube. Its contact angle is 0, and the surface tension is the same as that of water at 20 degrees Celsius.
He said, give one mask to someone. He said, he gave his wife mask to someone. She got mask.
Sir, I have a question. Sir, I have a question. Hello, sir.
Okay, now you that have question, reserve your question. Let me finish up because you have interrupted this class so many times. So the remaining question at the back, the remaining time, if you allow me, I will allow you to ask questions. But in as much as you are disturbing my schedule, you may not have that opportunity. I know what you guys are doing, but you're going to meet me there. In the exam hall, we will see. So I'm going to finish up, either you like it or not. All right, that is the second example. The third example, a capillary tube of 0.05 centimeter ball stand vertically in a wide vessel containing a liquid of surface tension 39 per centimeter cube. The liquid wets the tube and has a surface gravity of 0.8. Calculate the rise of the liquid in the surface. All right. Okay. From the formula we have before, we know that T, we can manipulate the T, which is the tension, make the tension the subject of the formula. Remember, I told you that formula is very, very important. And then play around with what you have. In this particular question, you will see that you are not given the radius, you are given the diameter. So you need to take note of that. The unit must be the same thing. Convert all the units. Must have the same unit throughout. Your unit must be the same thing throughout. And that unit is very, very important for you to take note of. All right? I told you I will give you time to ask questions. I will give you time to ask questions. Write down the example and let's finish that. So if you allow time to, we have excess time, there's going to be room for questions. But by the time you interrupt the class separately, I am not going to give you time for questions. So let's finish and then you can ask me questions. This is another example here. And you are given a liquid of density . Okay, so this is another example. Here we are to find the rise of the temperature of the liquid in the capillary tube. Again, we are playing with here is the unit. Remember, agree. The unit must be the same thing throughout. If the units are not the same thing, you have to convert the unit to the SI unit. That is very, very important. And I want you all.
He stopped being the canon and he became Mariah Carey's husband.
Yeah.
Yeah. That was his problem.
Now, another example.
Well, then I divorced her. How's that working for him? So what? Are you sure? You can hear us.
The computers, man.
There's even class now, so. Huh? They've all gone. I swear there was queue there. The day I came first, we didn't have my chicken number, so this is what I put. So, you think I should ask the man?
Mute yourself.
The next example, we are to calculate the density of LT alcohol. Here, the height is given. You are still talking. Oh, if I get you, now you'll be crying. When I handle you, you'll be crying. Stop. If you are not interested in the class, log yourself out.
Neti Ako 14.2 capillary of videos.
You have to number them. What if you now got on that one there? What do you remember?
And this one requires us to find the radius. If I were you, I will write the questions down. This will enable you to make use of the formula that has been taught. All right? That is very, very important. The wise one among you will put this one down. It is the same formula we have been using since the beginning. We've calculated the surface tension, we've calculated the angle of contact, we've calculated the radius, and we have calculated the density and the height of the liquid. Meaning that all the variables in the formula, we have used them. This is another suggested book for you. You can get this book in the school bookshop. It is in the bookshop. And go down there if you like and get it. So we continue with our work example.
When the money was for Ghana trip, it has been used partly already, but I know that it was not significantly less. I have information. I'm not saying to my client. I'm not going to give you I think we can bring it to the welfare because we have 1.5.
Now, example 1. When there are no external forces, the shape of a liquid drop is determined by class. When there are no external forces, the shape of a liquid is determined by, that is your test, quick test, class, quick test.
Surface tension of the liquid.
Surface tension. Surface tension.
Surface tension.
Surface tension of liquid.
Question number 4.
Face tension.
2 and 3.
Raindrops are spherical in shape because of what?
Surface tension. Surface tension.
Surface tension.
Surface tension.
Surface tension, sir.
Surface tension.
And check on the door. If there's not opening your eyes, put that one.
Surface tension, sir.
The surface of water in contact with the glass wall is
Concave.
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 if common salt is dissolved in water, then the surface tension of the water is
Decrease.
Decrease.
salt is dissolved in water. Then the surface tension of the salt water is
Decrease.
Decrease.
drop of oil is placed on the surface of water. Which of the following statement is true?
It remain it as a sphere.
Remain on
it as a sphere. Remain on
Spread
it.
as thin layer. As a thin layer. It will spread as a thin layer.
It will spread as a thin layer.
It remain on it as a sphere.
Partially as a spherical droplet and partially as thin.
You drop the spread, it will behave like a stretch elastic skin. That's what tension effect. It should be B or C.
Samuel Paul, what is your question? Some people I'm not going to allow them to ask questions because they've been making noise. I can see the record here. The noise makers, I can see the record here. So you don't have opportunity for question in this class. Noise makers, I've seen you. Samuel Paul, what is your question now, Samuel? Samuel.
My question was for the first example.
Okay. What happened there?
The parameters that he gave us, there was gamma there, and all of a sudden the gamma changed to T.
No. Paul, are you talking about this example?
The next one.
Paul, are you talking about this example?
The next one. Not this one, the next one.
Paul.
This one, yes,
Paul.
this one. I'm hearing, sir. Yes, sir.
Paul.
I'm hearing you, sir.
Hold
am I
on,
muted?
Paul. Hold on, Paul. Hold on,
Oh
Paul.
no.
Paul, hold on. The noisemakers, I want to differentiate between you and the noisemakers. Okay, go ahead with your question.
The gamma is 0.073. So all of a sudden the gamma changed to T, and I don't know what that T is. So that's why I was confused.
Say that again.
The gamma is 0.073.
Yeah.
But if you are checking in the solving, the gamma changed to one capital letter T, and I don't know what that is.
Okay. You see,
Yes.
that should be an error from this calculation. Listen
Okay.
now. Listen now. Listen now. Oh yeah, listen now. The gamma is the surface tension.
Okay, the gamma is surface tension.
And the T here is surface tension. That should be a topographical error.
Okay.
That should be a topographical error. Gamma and T are the same thing. Yes. Okay, Paul, are you satisfied?
Okay, so gamma and surface tension, they are the same thing.
See, the T here represents the surface tension. They are supposed to be gamma, as you have it here. T has no room here. You understand?
Yes.
It's supposed to be gamma, as you have it. When you follow it from up.
Yes, I understand, sir. You can carry on.
It's a symbol to represent surface tension.
Yes.
Like you use A to represent acceleration due to gravity.
I understand, sir. Let me mute my mic.
Okay, now that we have that, if you look at all the examples we have, that formula is very, very important to understand. That formula remains the basic concept of our calculation. So remember that one, you must be able to recall that formula. Two, you must make sure that all the quantities represented in the formula have the same unit. Their unit must agree. This example 6 is showing that the height is 14.2 millimeters. You cannot use 14.2 millimeters directly. So you have to convert it to meter, which is the SI unit. Because the radius is in SI units too, the density, which is rho, is also in SI units. The degree is not in radians, but it is in the angle is in degree, not in radians, SI units. So we are ready to substitute all these quantities into the formula. Do you guys have a platform? Bob?
Yes.
Yes,
I've
sir.
been raising up my
Yes,
hand
sir.
since.
So
Yes,
that I
sir.
can
No,
forward
sir.
this work example to you all.
Yes, sir. Yes, sir. We have it. We have, sir.
Are you going to send the notes?
Entire slide.
Sir, are you going to send the notes?
Yes, I want to send it to you.
Okay, sir.
Okay, you have
Okay,
been
sir.
raising up your hand. I'm sorry. I'm going back there to see you.
Yes. No
Sorry for
problem,
that.
sir.
A lot of people here. Olobo Okeremiri, I asked to talk, and you are talking, so I'm not going to answer you. No. Olobo Okere is supposed to.
I did
Those
not talk,
that
sir.
have their hand up, waiting for me to make them to talk, are the people I'm going to answer. Those people that raise up their hand and I don't ask them to talk, those ones I will remove them from the system. So, Chukwu Kumeneya, you are the next person to talk. Chukwu, go ahead and talk. Chukwu, go ahead and talk. Ọlọ́run ṣàánú. Okay, Chukwu is your turn. Chukwu Funaya. Is Chukwu not there? Okay. Abdullahi, electrical.
Oh,
Yeah, go ahead.
So I want you to explain that convex and concave lens. Convex and concave in that exercise. There's a question there.
Where were you when I was explaining it?
No, the one you explained was the one for the fall and rise. I understood that one, sir.
No, I already explained that when I was explaining adhesion and coercive force. When I was explaining adhesion and coercive forces, I already explained that.
Please, I have a
That
question.
means you're supposed not to come. That means you're supposed not to come on board again because you are the one stopping the class previously. Say that again. You have a question there.
Yes, I have a question.
Okay.
Good afternoon, sir. So my question is, remember one of the questions, the one where
I
we
did
had
not
to
ask
talk.
you to talk. Now, who is talking? Who is talking?
It's me, Ashinze. Funaya.
Aziz, what do you call your name now?
Ashinze Chukwu Funaya.
Okay, Chukufunaya, go ahead and ask your question. Chukufunaya,
Yes, sir.
Funaya
So
have the floor.
So my hand is up. It's up.
Go ahead, Chukufunaya.
Okay. So my question is, remember one of the questions where we were asked to find the radius of the tree for the sap to rise up to the top of the tree. Are you with me?
Okay, go ahead.
Yes. There you made mention of the temperature of the liquid as regards
Some
to the
people
surface
are
tension
talking
of
about
water.
Chukufunaya. Who are those?
So I said you made mention of the temperature as regards to the surface tension of water. But in that equation, we did not use it. Are there scenarios whereby we will have to make use of the temperature or the temperature of the liquid affects the surface tension?
Please repeat yourself, please.
I said you about the question whereby we were told to find the radius of the capillary tube of a redwood tree if the sap is going to rise to the top. You made mention of the temperature as regards to the surface tension of water. But in that question, we didn't make use of the temperature. So what I want to find out is whether
we did not. What
we
question
didn't make
is
use
that
of
one?
the question about the redwood tree, the radius of the redwood tree. Yes. No, no, redwood, the one of the redwood tree, where you said the surface tension is the same with water at 20 degrees.
There's a kind of wait now.
This is the question. Sir, can I go on?
Dr. Dala. Okay.
Sir, you said
the
surface tension.
Now listen, if you want me to answer your question, don't allow this thing to vibrate. No echo.
Okay, sir. Sir, what I was saying is, you said the surface tension is the same as that of water at 20 degrees Celsius. But here we do not make use of the surface tension of water, neither do we make use of the temperature. Are there scenarios whereby we have to make use of the temperature, or the temperature affects the surface tension of the liquid?
Funaya, go ahead.
Okay, sir, as I was saying, you said the surface tension is the same as water at 20 degrees Celsius. So, and in this equation, we didn't make use of the temperature. We just made use of the initial surface tension we were given. So what I want to ask is,
wait.
do we actually... Sir?
Wait.
Sir?
Wait now. Wait. They sure know. Can you type this question out for me? There is a crosstalk here. Can you type this question to me?
Yes, sir. I'll type it now.
Thank you. Oh yeah, type it. And if you guys have a platform, let me know the platform to send you the material. Oh yeah, where is the question? Okay. Yes, I say cases where we will use the temperature in the equation, or does the temperature affect the surface tension? Yes.
Hello. Anybody online?
No one is online.
Why are you asking? Are you online?
With a bomb. With a bomb.
You the bomb. All right, class. Chuku, send me where to send the material. Chuku Fire. All right. Thank you. Bye-bye.
Sir, please, I want to say something.
Oh, who is that? Who wants to say something?
My
What's your
name is
name?
Felicia. Felicia.
Eh?
Felicia.
Okay. Did I
Yeah.
log you out?
No, sir.
Okay, go ahead, Felicia. Linda
I'm the vice course rep of medicine and surgery. And
you
you
are
are
the class
asking
rep, right?
vice course rep. You were asking where you can send the material. So maybe I
Yes,
should just
Felicia.
drop my number.
Can
I drop my number in the chat box?
Where is that number now?
I want to drop it now in the chat box.
Is that Felicia? Is that you? 091?
Not yet, sir. I've not dropped mine.
What is this
So I
091?
just dropped it. 090 2970 7276.
Okay, I'm coming. I have so many numbers now. Felicia, let me just take it.
Sir, so when you send the slides, I will help disseminate to medicine and surgery and the pre-med group.
Please send it to all groups. So send it to all groups.
I'm coming. I'm looking for it.
I've heard. Whoever, I will send it to all groups.
Okay.
I'll just post it on the general group.
Call the number out.
090 29 70 29 70 090 29 70.
Okay, wait. I'm going to post my number now.
Okay, yeah. That's better.
I'll post my number. But
okay.
I'm not going to send it to the people. As soon as you write your phone number, listen. As soon as you write your number, tell me the group you are representing.
Okay, sir.
You understand that?
Yes, sir.
Tell me the group you are representing. Don't worry. Just take this number. I believe you can see it now. That is the number of the lecturer.
0816. Is that
Can you see it?
So I did the 0816.
Sir, we don't see, sir.
Can you see my number there, everybody?
I've seen it, sir.
Sir, is it 0816?
Yes, sir. 0816.
That number that ends with 5, that is the WhatsApp number. Naya, can you see it?
No,
No
sir.
number ends with 5.
No, sir. No, sir. Sir, I haven't seen the number, sir.
Sir, I've seen the number. I'll message you now. The number is 081 344 3165.
Thank you. Call it to them.
081 344
Wait, sorry.
3165.
Call it again. Sorry. 081.
081
Mm-hmm.
344 31
Yes.
65.
Okay, thank you.
Thank you. Bye-bye.
Bye-bye.